Alright, so today in class we went through the idea that when you have a simple trig equation, sine theta equals a half is the example we were doing, that in year 9 it was okay to have our one answer, that's no problem, but now that we've looked at angles of any magnitude, we can get multiple answers. In fact, we can get an infinite amount of answers. But because we don't want to have to write out an infinite amount of answers, and as I said to you before, in year 10, you're really expected to find the first two answers. And so when we have a question like this, we tend to have our domain restriction, that is the restriction on theta, our answer, being between 0 and 360 degrees. Now that means, as we were talking before, that we should get two answers. So what I'm going to do is I'm just going to go through the steps that I use pardon me, to find those two answers. The first step is to think about this ratio. Now this ratio gives you two pieces of information. Okay, the two pieces are the sine of that ratio and then the magnitude of that ratio. The sine tells us what quadrants we're in. As we know, all of the three trig ratios, sine, cos and tan, are positive or negative in each of the quadrants. So the sine of this ratio is going to tell us which quadrants we are in. The magnitude is going to tell us what the equivalent acute angle is, which is going to be the second thing that we work out. So let's have a quick think about this one. In this case, we have a positive 1/2. Now we're dealing with sine, so what we have to do is have a look at our quadrants and think about the quadrants that sine is positive in. In this particular case, we know that sine is positive in this quadrant and in this quadrant, the first and second, all stations 2 central. That means our two answers are going to be in the first and second quadrant. The next step is to work out what our equivalent acute angle is. So in this case, we would go to our calculator and we'd say, well, our equivalent acute angle, which is often given the symbol theta hat, is equal to the inverse sine of 1/2. Now notice that we take the positive of that, and we'll talk a little bit about that again later, but we take the inverse sine of 1/2, we use our calculator for that, or we can remember our exact values, and it turns out that's 30 degrees. That means that we know for sure that the sine of 30 degrees is equal to 1/2, but 30 degrees is not our only answer. It's our equivalent acute angle. So what we do is we combine those two things. We take the sine of what we have, and therefore the quadrants we are in, which in this case is the first and second quadrant, and then we use our equivalent acute angle, that's this one here, to work out what our angles are in the quadrants that we want. So in this case we need the first quadrant, that's super easy because that actually is 30 degrees, but then we need the equivalent angle in the second quadrant. Now back when we were working these out, we came up with this idea to go backwards. That we said if we had the angle 110 degrees, for instance, the equivalent acute angle to that is 80 degrees. Because if we have 110 degrees, which is in the second quadrant, the triangle we make makes an angle of 80 degrees with the x-axis. Therefore, the equivalent acute angle will be 80 degrees. But now we're going backwards. Now we're starting with this angle here in the first quadrant, and we're trying to work out what the angles are. The equivalent angles are in all of the other quadrants. So in the second quadrant, it's nice and easy. Okay, it's always going to be 180 minus whatever it is in the first quadrant. So in this particular case, we know that in the second quadrant, the equivalent angle is 150 degrees. And those are our two answers. So we can say that if sine theta is equal to 1/2, then theta is equal to 30 degrees and 150 degrees if we're only looking from 0 to 360.